When you are told to solve a system of equations by graphing, if you have a graphing calculator, this will be very simple. You will draw the two equations on the graphing calculator and find the points where they intersect. But let's say I don't have a graphing calculator and I want to solve this equation by graphing. I'll go back to what I've learned in the past and identify the things that we know. For example, the first equation given to us is y plus x plus 2 equals 0. By looking at the equation, I would expect getting a straight line on my graph. This is a linear function. It doesn't come with an x squared. The second equation will give us a parabola because it consists of the x squared. If I can rearrange the term, we will see a trinomial for the second equation, and that will give us a parabola. If I want to solve this system by graphing, I'm going to draw the linear with a blue line. Y equals mx plus b. Here is the y-intercept, and here is the slope. Starting with -2 on the y-axis, I can draw this line using -1 for the slope. We would expect to see a line that goes downhill from left to right. Use a ruler to join those points together. I don't have a ruler, so that's the best I can do. So here is the graph of this linear. For the second one, the parabola, the quadratic equation, -3x squared plus 2x plus 4, we would expect to see a parabola that opens downhill with y-intercept at +4. We would expect a point here. We would expect a parabola that opens downhill. And we would expect a parabola that gets stretched out by 3 times. But having just the y-intercept wouldn't give us a parabola. You probably may want to come up with the vertex. And at the beginning of the year, we have learned how to identify the vertex of a parabola. -b divided by 2a. That's the equation we could use to find the x-coordinate of the vertex. We have 2 for the b, and we have a equals -3. So that would give us 1/3 or 0.3 repeating. We would expect having the vertex at 0.3. And this vertex will be on the axis of symmetry. We would expect having a parabola with axis of symmetry at x equals 0.3 repeating, or 1/3. But still, you want points. We want points to draw this parabola. You can find the y-coordinate of the parabola by substituting the x-coordinate into your equation. Once you substitute the x-coordinate, you will be able to find the y-coordinate of your vertex. Y-coordinate of your vertex would then be -3 times 1/3 square plus 2 times 1/3 plus 4. 4 1/3. giving us a point that is a little bit above y equals 4. That will be the vertex of your parabola. Once again, we expect more points than this. If you want to draw the parabola using a table of value, you can start with some random numbers, trying to get a sense of how the parabola will look like, and draw it. For now, we would expect a parabola that opens downward, probably that go this way and that way. But we want points. And substitute each of these x value into the equation and find the y coordinate. Let's say if we have -2 for x, we will end up getting -3 times 4, -12. -12 minus 4 plus 4. That's -12. Well, that's a big number. We don't have enough space to plot this point on the graph. If we want to move on to the next one, when x equals -1, what is the y coordinate? Continue to do your calculation until you have a few points to work with. This is what I would do using a table of values. Now, of course, if you have a graphing calculator, things will be relatively simple. Get your calculator to draw it. I'm going to show it to you. But for now, if we don't have a graphing calculator, I'll set up a table of values and draw it. We have -1, -1. Here is a point. And then we have 0 and 4. That's the y-intercept. 1 and 3. 1 and 3. And then 2 and -4. 2 and -4. While these 5 points don't look symmetrical, once you join these 5 points together, we will see a parabola, and this parabola will be symmetrical with the vertical dotted line, x equals 1/3. And once you have a graph for both the parabola and the straight line, you can then identify the points where they intersect, and these are what we call the solutions. In this case, the solution to the system would now be 2 and -4, and there is another point here. It is at -1, -1. So this is how we solve a system of equation by graphing manually. If you have a graphing calculator, your calculator will do everything for you. So here, if I have a graphing calculator, I will enter both equations into my calculator. Negative x minus 2 and negative 3x squared plus 2x plus 4. Get my calculator to draw both lines. And I want to make sure the window is good in shape. So now I have some big numbers here. Let me change it back to something that you want to use. Here is the line, the straight line, and the parabola. You can get your graphing calculator to show you the table. If you go second and table, you will see the points on both lines. Plot these points on your graph so that you can find your solution. Or you can get your calculator to calculate the solution. Second, calc, and find the point where they intersect. Your calculator will give you a few questions. Is this equation up here, negative x minus 2, the first equation you want to work with? Press enter for yes. And now, do you want to use the second equation to be your second curve? If this is the right equation you want to use, press enter. Now on your screen, it comes with two intersections. There are two solutions on your graph. You can now move your cursor to the point where you want to find and get your calculator to estimate the solution to you. Negative 1, negative 1. And if you want to find the solution on the right-hand side, you will redo the same process. And this time, you will move your cursor to the right-hand side and get your calculator to find the point here. And here we end up getting to a negative 4. So this is one way to verify the solution. If you want to verify your solution manually, what you can do is to substitute the numbers into both equations. For now, so if I just check it manually, if I want to verify whether this point is the solution or not, 2 and negative 4, I will substitute these two numbers into both equation 1 and equation 2. I want to make sure that the left-hand side and the right-hand side are equal. When y equals negative x minus 2, I will substitute positive 2 for x and negative 4 for y. And if they are the same, if the left side and the right side will be the same, that means it works for one equation. I will try it again with the second equation. Y equals negative 3x squared plus 2x plus 4. Substitute both x and y again into the second equation. And I want to make sure that the left-hand side and the right-hand side equal to each other. Equations must hold if you want that point to be your solution. If that point will only work for one equation and not the other, that's not a solution. So doing the same thing for the second point, with y equals negative x minus 2. If it is correct, we will try the second equation. Y equals -3 times 1 squared plus 2 times 1 plus 4. Both equations must be correct. 1 point to be your solution.